Okay, so we are recording right now. So hello everybody, welcome to Sonel Training. My name is Peter Polik, and at Sonel I take care of trainings and technical support. And today we will see what we do at Sonel and for which applications we can use our products. All right, if you have any questions, well, we are live here. We have the cameras, we have the microphones, so ask me during the presentation. All right, so at Sonel we can split our activities to like main 4 groups. So first of all, we do different measuring instruments, and we are going to focus on this. Further on, we have accredited calibration laboratory. We perform trainings, and also we perform electronic assembly. Well, the main part of our activity is making those meters for electrical installations. So right now, let's see where we can use these meters. And here we can see the power network, which we have divided into power production. So here's the production, then transmission and distribution, and consumers. So right now we will discuss different types of power production. We will discuss the transmission and distribution and different types of consumers to see where we can use the meters and what type of meters we can use at these different facilities. So first, let's look at the power production. I'm going to differentiate here the solar, wind, and the remaining types of power plants. So right now, let's look at all the remaining types. So this could be a coal plant, a gas plant, a nuclear plant, or maybe even water plant. So when we look what type of electrical instruments we can find in the plant, well, definitely there are generators, there are some cables, and there's a transformer, which further on will lead into the energy into a distribution or transmission lines. So the generator we can test with insulation resistance meters. So that's the MIC series. And we can test the insulation of the windings of the generator. We can also check continuity of those windings, so then we can use the micrometer. Definitely everything is grounded here in a power plant. So for that, we can use the MRU series, especially MRU 120 or MRU 200. These are our earth resistance meters. As well as we can check everything with thermal imaging cameras to make sure that the things are not overheating. I wonder, Robert, if you could turn your microphone off because we got the background noise.
Okay, how to do it? Because
just underneath your face, there's a little bubble with the microphone. So
yeah, but I cannot see my face.
Yeah, underneath the black thing.
No, what I can see right now is only your screen.
Okay.
Can you do it for me? Can you?
I can shut you off, but then when you would like to say something, we wouldn't be able to hear you. Oh, we got Joseph and Raymond joining. Hold on, so I will give the camera and microphone to Joseph and to Raymond, microphone and the camera. Okay, gentlemen, so I gave you a possibility to speak and to share the camera. To do that, first allow your browser to use the microphone and the camera, and then underneath, okay, I will share my screen. So underneath our faces, you got those little bubbles. So here you can turn on and off video and on and off the audio. So then you will be able to speak and we will be able to see you. So these are the bubbles over here. But anyway, welcome on our training. And today we are discussing our meters by application. So I will show you different places where we can use the meters. Here you have some graphics, but it will be good for you to learn those three letters that represent different series of the meters, because on the graphics we could put just so much. So for example, MIC, that's the insulation resistance meter, MMR, that's a micrometer, MRU, that's earth resistance meters, KT, these are thermal imaging cameras. So so when you know these three letters versions, then you know which type of meters we can use in different places. Okay, so I will continue. If you have any questions, just turn on the microphone and you can ask them live during this presentation. Plus, everything is recorded, so I will share the recording with you once we are done. All right. So first I showed the type of power network. We have different types of production, we have transmission and distribution, and we have different types of consumers of energy. So we will talk where and what can we use. Now, as it comes to power production, we will differentiate the solar and the wind. And the remaining ones like water plant, coal plant or gas plant or nuclear plant, I will discuss just over here as generally a power plant. So in a power plant, we can find a generator, transformers, and different cables. And we can test them with our meters. So for the generators, insulation resistance of the winding with MIC series, continuity of the windings with micrometers, MMR series, and earth resistance, because everything needs to be grounded. That's MRU series for earth resistance meters, especially MRU 120 and MRU 200, because they are using higher measuring currents, which are suitable for the power industry. And of course, we can check if any component is overheating. So we can do this with the thermal imaging cameras of KT series. Then further on, we have cables leading from the generator to a transformer. And we can check those cables also to make sure that their insulation is correct. So that's MIC series. We can check their continuity with the micrometers. In case we would like to trace the cable, then we can use our locators of LKZ series or TDR, so time domain reflectometer, to make sure that the cable is not broken at any point. Now on the termination or any connections, we can check for partial discharges using the test PD meter. And we can also use PQM, so power quality meters, to make sure that the power plant is producing good energy of good quality. Now, further on, let's go to a transformer. And here we can check insulation resistance of windings of the transformer. So that's a MIC series. Continuity of those windings, so micrometers of MMR series. Again, grounding, so that's MRU 120 or MRU 200. We can check if there's any corona effect, especially on the outside insulators of the transformer. So we can do that with the UV camera. We can check if there are any faulty elements, so those would be overheating, and we can do that with thermal imagers of KT series. And to make sure that the power that the power plant is producing is of good quality, we can use the PQM meters, so our power quality meters. Probably here we will need to connect them with transducers, because power quality meters are designed to work at a low voltage up to 1000 volts, and here we can expect something higher. One more thing here, depending on type of plant and the type of transformers and generators that they are using, it may happen that some of them will require more powerful meters that we have. So if you have, for example, a big block transformer, first you need to check what are the specifications of the transformer to make sure that our meter is powerful enough for those. Okay, now let's look at the other type of plants. So here we have a solar plant. And here we have all the components of the plant. So we have photovoltaic panels, the combiner box. We may have some battery system for the storage of the power. We will have the converter from DC to AC, and of course transformer that will lead the power into further on transmission network. So what meters we can use? Now to check the electrical safety of the solar panels, we can use PVM 1020. So that's the meter to check electrical safety of solar panels, together with IRM1. So this is the meter to check the solar, so the irradiance meter. It can just check how much of the solar the light from the sun is coming to the panel, what is the exposure, what is the temperature of the panel. Now we can find these functions also in our multifunction meter MPI 540 PV, which we can also use to check solar panels as well as other parts of the electrical installations. To check for any hotspots on the panel, we can use either thermal imager or the infrared pyrometer, so KT series or DIT series. We can check what is the current flow. So for that, clamp multimeters, CMP series. We can also check insulation resistance of cables here connecting the solar panels. So that's the MIC series, and the grounding with
the slide,
meters.
The slide are rotating. Cannot see the slide.
You cannot see the slide.
Okay, still spinning.
Okay, I'm thinking this should be possible. Do you see?
Now can.
Now it works. Now
it doesn't work now.
Okay, how about the other people? Can you see the picture? This should go automatically from the click meeting. Okay, let me change the view. Our cameras and back to presentation. Can you see it now?
Still rolling, still rolling. I don't know whether my network here is on or your network there.
Hold on, this is a picture showing the solar plant.
This is just a...
Wait.
I can see this. Okay, I can see this.
Mm-hmm. Okay.
Now can. Okay.
Okay,
sorry.
Okay, no problem. All right, the next part of the solar plant, that will be a combiner box. So here we can use, again, PVM 1020 or MPI 540 PV. We can also use the multimeters to check voltage, current, and other parameters, and make sure that nothing is overheating with thermal imagers of KT series. Now, in case of storage system, so the battery chain, here we can use we can check the continuity between the batteries. So for this, we can use MMR 6500 or 6700. That's because they work together with clamps, and we can check if there are any leakage currents. We can check the continuity of a battery string, and we can check voltage and current using the multimeters and clamp multimeters, and make sure that nothing is overheating with thermal imagers of KT series. Because of course, if we have a faulty battery, we should be able to see that it is overheating. Okay, so now the next thing, this is the DC to AC converter. So here we can check it again with PVM 1020 or our MPI 540 PV. Now there's a special function in these meters to check the efficiency of the inverter. So we can connect on the DC side, on the AC side, and then see how well it works. Also, we can do this with power quality meters. So that's the PQM series. We can check if there are any overheating elements with thermal imagers, so KT series. And we can check the short circuit loop using the MZC meters. All right, and now we got to the transformer. So in a transformer, we can check the windings, their insulation with insulation resistance meters of MIC series, their continuity with micrometers MMR series. We can check short circuit loop impedance with MZC series. We can check the grounding of the transformer. So that will be MRU 120 or MRU 200, the ground resistance meters. Any overheating elements we can find using thermal imagers of KT series or pyrometers of DIT series. And to make sure that the energy that we are producing is of good quality, we can use the PQM meters, and probably we may want to use the transducers over here to connect the meter. So yeah, so these are the solar panel plants. Now let's look at the wind plants. So here we have example of a wind plant. And of course, we have the wind turbine. It has a generator. Then there are some cables leading to a transformer. Of course, there is a transformer, which will lead the energy into the network. And of course, all of the components of the system, they have to be grounded. So what we can check here, we can check the generator over here. So we can do that again to check the insulation of the windings using insulation resistance meters, MIC series. We can check the continuity using the micrometers, and we can check if any part is overheating with the thermal imagers, so the KT series. MIC insulation, MMR micrometers, and KT thermal imagers. Now we will find the cables leading from the generator to a transformer. So in cables, we need to check their insulation. So that's insulation resistance meters of MIC series, and their continuity using the micrometer. Now the wind turbines, the towers, they have to be grounded. So for that, we will need the MRU 200 or MRU 200 GPS. So we will be able to check the earthing of such tower. And further on, the wings of the wind turbine, they need to be connected to the grounding as well. So here we can use the micrometers of the MMR series to check the connection between the wing and the grounding. So for that, we can use the micrometers. Now to check the power quality of power which is produced by this wind turbine, we can use the power quality meters. So we can connect them before the transformer or behind the transformer. That's the power quality meters together with transducers. And on the transformer, same as in the other power plants, we can check insulation resistance with MIC meters, continuity with micrometers. We can check short circuit loop. So here we can use MZC 330S or MZC 306. That's because they can work with higher nominal voltages, so up to even 690 volts. They can calculate the short circuit currents. So you can use these two meters. For checking earth resistance, we have MRU 120 or MRU 200. We can check any overheating components with thermal imagers of KT series or pyrometers of the IT series. And we can check for a corona effect using the UV camera. Okay, so these are the power plants. They produce energy, and now the energy will get into our transmission and distribution network. So here we have the picture showing the transmission network. So we have here for high voltages, medium voltages, and the distribution. So that's for low voltage. However, if you look closely at this picture, well, there's plenty of going on, but generally we can use the same meters for the substations. We can use similar meters for checking pylons or checking the cables under the ground. All right, so let me go through this. So we've been to the different types of power plants. They had a transformer. Transformer leads the energy into the network. Now in this network, we can have either the transmission towers, in case this is an overhead line, or we can have some high voltage cables which will go under the ground. So in case of transmission towers, what we need to check it is we can check for any partial discharges, corona discharges. So that's our UV camera. And we can check if there are any overheating components like the insulators on the pylons. So that's with the thermal imagers of KT series. Sometimes if the towers are really tall, you can use the thermal imager together with the tele lenses. So that will be with our higher models, KT 560, 650, or 670. We can also check insulators on the tower. So when there is a maintenance period, the power is shut down, we can use our insulation resistance analyzer MIC15K1 to analyze the insulators on the tower. Now the other scenario will be when we are not using the overhead lines, but everything goes in the cables under the ground. So here to check the cables, we can check their insulation resistance. So that's the MIC series, MIC meters. Oh, sorry, let me go back. One more thing, what we can check with the towers is the earth resistance of the tower. So for that, we can use MRU200 together with ERP1 adapter. The ERP1 adapter allows to use flexible coil to check the earth of the transmission tower without disconnecting the overhead line. So that's the special adapter which we can use with this meter. Okay, so that was the towers. Now let's go to the cables under the ground. So here we can check insulation resistance of these cables using our insulation resistance meters of MIC series. We can also check the insulation strength using VLF, so the very low frequency, or the high-pot DC tester. So here it depends what types of cables there are under the ground. Generally, the high-pot DC tester is for the ones in paper insulation, and with VLF we can check the strength of insulation of cables, for example, in polymer PCV insulation. Further on, we can check for any partial discharges in those cables, especially when we are thinking about the terminations, so connections on one end and the other end. Also, in case there are any connections, any muffs in the cable. So we can do this with a test PD meter. That's the meter for partial discharges. And further on, for any maintenance, when we want to locate a fault or trace the high voltage cable, we can use LKZ series. So that's our cable locators, and time domain reflectometer. So that's the TDR series. So LKZ, that will be the bigger models, 1000, 1500 or 2000. The LKZ 720 is a small one, which is designed more to be used in inside buildings. And LKZ 1000, 1500 and 2000, they have very big antennas, so we can trace the cables under the ground. And the time domain reflectometer, it just puts a pulse in a cable, and it's measuring the reflected power of this pulse. So it will check if there are any breaks, any shorts, open circuits, connections. Yeah, so it will tell us what's going on inside the cable and how far from the beginning, so from the moment we connect the TDR to this special effects, if it's a connection or break or whatever. Okay, so we went through the transmission line. Now we have a transmission substation. So what we can do this here for the whole station. Well, we can check insulation resistance of different components with the insulation resistance meters. So that's the MIC series. We can use the micrometers of MMR series to make sure that there's continuity between different parts. We can use the UV camera to check for the corona effect on the insulators and any parts here above the ground. We can use the test PD meter to check for partial discharges on the cables. So when we have terminations of the cables incoming or outgoing. So here we can check using the test PD meter. We can use thermal imaging cameras, so KT series, to check for any overheating elements. And we can use the PQM meter to make sure that the power quality is correct of the incoming power and the outgoing power as well. Now we can also see here MRU series, so the earth resistance meters. Of course, the substation has to be grounded. And especially here, you can see the MRU meter. So this meters are used to check the earth resistance of the whole substation or of different components. Again, as we are talking about the application for power and energy for the utility companies, then we will need to use MRU 120 or MRU 200 as they have higher measuring currents. Now in substation, we can find also some particular elements. Like here you can see this is the breaker switch, well, some breaker switch. So what happens here? We need to make sure that the contacts on the switch is correct. And we can do this with MMR 6500 or 6700. So our micrometers. And they are special because they use higher currents. So MMR 6500 use up to 100 amps, and the MMR 6700 they use up to 200 amps. So here the whole trick is that when the breaker connector is closing, we can have an arc burning on the connectors for some time. And it can leave the carbon on the surface of the connectors. So we need to make sure that there is a good connection between those connectors, of course, but to get rid of any resistance of the carbon, we need to use the higher currents. So that's why we need to use the meters with higher measuring currents. Now, as we look at the transformer itself, well, we can check here the insulation resistance of the windings. So that's MIC meters. We can check with micrometers the continuity, and we can use thermal imagers. So the KT series to make sure that there are no overheating elements. All right, so that was the transmission substation. Now let's go into a medium voltage, so between 1 kV and 60 kV. And here basically we can have similar elements of the system. So there could be an overhead transmission line, there could be cables under the ground, and this will lead us to the distribution station. So what we can check in case of overhead transmission line, here again on the towers we can check for any corona discharges, UV camera, overheating elements with thermal imagers, and we can check insulation resistance of the insulators using the MIC series meters, so insulation resistance meters. As it comes to the grounding of the pylon, we can use here MRU200 together with ERP1 adapter, again designed to check the earth resistance of the transmission towers without disconnecting the overhead line. Now, when we are talking about the cables, similar as in case of high voltage, we can check their insulation resistance with MIC meters. We can check their strength with the strength of dielectric insulation using VLF or DC hypot testers. We can check for partial discharges, especially at the terminations of the cables, as well as on any connectors or muffs. So that's the test PD meter. And in case we want to trace the cable and make sure that there are no damages inside them, we can use LKZ locators or TDR, the time domain reflectometer. Okay, so we got to a distribution substation, and here's a similar situation like on the transmission substation. For the whole station, we can check insulation using insulation resistance meters of MIC series, any continuity, that's the micrometers of MMR series, corona effect with the UV camera, partial discharge on cable terminations, that's test PD, thermal imagers of KT series. With them we can check for any overheating elements, and power quality with PQM, our power quality meters. Now the groundings in the substation we can check with the meters of MRU series, so ground resistance meters, especially MRU 120 or MRU 200. Now, as we look at the transformer itself, we can check its insulation resistance with MIC meters or continuity of the windings using the micrometers of MMR series. And on the connectors, we can check the continuity of connectors, connector switches using the micrometers MMR 6500 or 6700. So basically the transmission lines, regardless if it's high or medium voltage, we can check with same meters. Also the cables, high voltage and medium voltage cables, we can check with the same meters, as well as we can use same meters for checking the transmission substation or distribution substation. Okay, so now let's go into a distribution system that will lead the energy to the consumers. So we are looking here at the low voltage below 1000 volts. And here we can have some overhead lines or some cables. In case of overhead lines, we can check with thermal imagers if there are any overheating components. We can check insulation resistance of any of the insulators, and we can check the earth resistance using the MRU meters, also in case we have the towers, then together with ERP1 adapter. And now we get to a transformer at the consumer. So it could be at the house, it could be at a factory, or any commercial, residential, industrial building. So this transformer, the low voltage transformer, we can check its insulation resistance using MIC meters. With micrometers of MMR series, we can check continuity. Here we can also check short circuit loop, and on the transformer station we will need to use MZC 330, 320, or the older model MZC 310. We can also check the grounding of such transformer using MRU 200 or MRU 120. We can check power quality with the PQM meters. So here on one end, from the consumer side, we can make sure that the power we receive is of the good quality. And on the other end, as we are, in case we are the energy company, we can make sure that the consumer does not introduce any distortions into our power, like any harmonics or any other troubles. And of course, we can check all overheating elements using thermal imagers of KT series. And now the cables leading from a transformer to well, probably to some breaker switches and then onto a house. So we can check the cables using MIC meters, so insulation resistance meters. Here we can also use our multifunction meters, MIC 525 or the future MIC 536 to use that to check the insulation resistance of these cables. And in case the cables are under the ground, we can also use the locators of LKZ series. So that happens just recently. I was showing to people from energy company that they wanted to locate which house in the residential neighborhood is connected to which breaker in a breaker box. So we were leading from, we were connecting the current clamps of the locators transmitter near the breaker, and then we are following with the tracer to a particular house. Okay, so that was the transmission and distribution. Now let's look at different types of consumers. So first of all, let's start with the residential consumer. And in case of residential houses, we need to check the safety of electrical network for the insurance purposes. And in residential houses, that's typically once in 5 years we need to do that. So in case there will be, say, like any fire coming from electrical installation, then the insurance company would pay the insurance to the homeowner, because we need to make sure that the electrical installation was safe. And we can do this with different meters. So first of all, when we have a switchboard over here, so we can check here for short circuit loop impedance using MZC meters. We can check the RCDs in case we have the RCD residual current devices. So that's with MRP meters. We can check insulation resistance using insulation resistance meters of MIC series. What else we need to check at home? We need to check continuity between different outlets and the main board. Also the main grounding rail together with the grounding here, together with different components of the network, different outlets. So we need to do that. And of course, we have the multifunction meters of MPI series, which have all of these functions in one meter. So especially for residential applications, we can use the MPI meters, and there we have all functions connected into 1 meter. Now further on, in residential houses, we need to check earth resistance. So earth resistance with MRU meters, and they can also check the continuity of our ground channel in the network. Now here on the switchboard, we can also check the power quality with the PQM meters. We can check for any overheating switches with thermal imagers, so that's KT cameras. Now on the PE channel, so on the ground channel inside the building, we can check for any leakage currents So here the CMP 2000, that's a small clamp meter which is designed for checking the leakage currents in Earth network. And in case we would like to locate a cable in a wall or a ceiling or a floor, we can use LKZ720. Also, we can use this LKZ720 to locate a particular switch which is connected to a particular outlet. So in this situation, we put the transmitter in the outlet and we look for switches on the main board. Also, with LKZ720, we can check if there's any breaks or shorts in the cables in our building, in our walls. Now, further on, let's look what we can find in a residential house. So definitely there are different outlets, and to these outlets we can have connected different types of appliances. So in the outlets we need to check short circuit loop impedance. So that's MZC series. We can connect the MRP meter here to make sure that our RCD switches are working correctly. We need to check the continuity of a PE channel between the outlet and the main grounding rail. So yeah, we can do this with all single function meters or just use one multifunction meter of MPI series to do all of that. Also in the power outlets, we can check the voltage. So there are VT testers. These are those little pen-like devices with the neon light on at the top. So when we put it close to voltage, it just flashes. We can use the voltage testers. So P4, P5, and P6. So these are little voltage testers. You put them inside the socket and they will show you what is the voltage. We can use the multimeters of CMM series. And these are the meters that we can use to check the outlets. Now, in case of different electrical appliances, here we have example of a washing machine. We can check safety of these electrical appliances using pad testers, so portable appliance testers. And now let's look what happened if this resident he decided to go green and he put some solar panels on the roof of his house. So here, similar like in solar power plant, we will need to use either PVM 1020 or MPI 540 PV to check the electrical safety of these panels. And any overheating elements we can check with any hotspots with thermal imagers or the optical pyrometers, so KT series or DIT series. Further on, it will go to the inverter, so DC to AC inverter. Again, PVM 1020 or MPI 540 PV. We can check with PQM what's the quality of the power coming from solar panels, and we can check any overheating elements with the thermal imagers of KT series. Now, in case this residential building has a solar panel plant or a thunder protection system, we need to check the grounding. And here, in case we have the panels, we need to treat this as a power plant. So that's MRU 200 or MRU 120. If we have the thunder protection, we need to check with MRU 200 because this is the meter that has a special impulse method, which reflects the signal coming from the thunder strike. So to sum up the earthing in residential buildings, if they have solar panels, then we treat them as the solar power plant, and we need MRU 120 or 200. In case of thunder strike, MRU 200. And if this is just a regular grounding system, then we can use any of the meters from the MRU series. Now, further on, what we can check in a residential building. In some cases, we may want to we may need to perform energy audit on the building. So to make sure that the thermal insulation of the building is correct. So either in hot places that the AC is not going out of the building. In the cold places, when we have the heating inside the building, we need to make sure that the heat does not escape. So for such application, we can use thermal imagers of the KT series, so thermal imaging camera. Okay, so that was our resident. And here I think that the most you can get out of the multifunction meters of MPI series, again with MPI 540 PV. In case they have the solar panels, also we can check the safety switches, we can check the continuity, we can check RCDs, insulation, earth resistance, so everything we can do with the MPI meter. All right, so that was the resident. Now let's go to more complicated consumers. This is the industrial consumer. Also, in some cases, you can think about commercial or office buildings, as they will have some similar components. Okay. So now we are coming from a transmission network, and the energy will get to our distribution board. So here is the main distribution board. And further on, we have some switchboards where we can find safety switches. So what we can do here, what we can test here. Again, we can test here short circuit loop. We can check the RCDs. We can check the insulation resistance. We can check the continuity between the safety switches, between different power outlets and the main grounding rail, which is over here. So that's with the MRU series. What else we can do here? Continuity. And we can also check the grounding of the whole industrial plant. So any of the meters from the MRU series. Of course, you can also find all these functions in the multifunction meters again. So again, the MPI series. So these are our multifunction meters. Now the other things that we can check here in the industrial consumer, that would be the, tracing the cables. So LKZ, especially LKZ 720, if we are talking about inside of the building. So here we can trace the cables in the walls. We can find breaks in those cables. We can identify switches. So when we connect a transmitter to the outlet, we can identify different switches on switching board. So that's what LKZ 720 is for. Also, when we are talking about the cables, we can use TDR, so time domain reflectometer, to make sure that the cables inside there are correct. So there's no break, there's no short, and we can see all the anomalies that happen in the cable. Also on the main switchboard, we can put a power quality meter. So here with this, we will know if the quality of the power that we are receiving from the energy utility is good, and what is going on in our own power quality network. Of course, we can also put PQM meters on different components of our network, because we can have some special parts in the installation, and then we want to make sure that these parts of the system, they don't disturb our power quality. Like, for example, we can have elevators, which are very high load devices, and they work, say, non-continuously, so they can mess up our power quality network, and well, we wouldn't like that. We can check, for example, the lighting, especially if we have some LED lights, they can put some harmonics into our network, so we can check each component of the network with the power quality meter. Now further on, let's look at other parts here of the installation. So we have the grounding system coming to the main grounding rail. And here we can check any leakage currents with CMP2000. So this is this small clamp multimeter used especially for detecting leakage currents. And of course, any overheating elements in the network, they can be checked using our thermal imagers, so KT series. Okay, now let's look at different parts of the network and different electrical devices that we can find in the industrial consumer. So there's the electrical outlet. It could be a single phase, it could be a three-phase outlet. And here again, we need to check short circuit loop, RCD breakers, insulation. So we can do this with the single function meters, MZC, MRP, MIC, or again, the multifunction meter of MPI series, which has all of these functions in one meter. Now, in case we have some electrical devices, then here, well, we have different people, different workers using these electrical devices. Like here we have electrical drill, for example. And there might be different rules and regulations regarding the electrical part of the devices, but usually every work law requires the employer to provide a safe environment for the employees. And now, as the employee is using this drill every day, then the employer must make sure that this drill is safe to the employee from the electrical point of view. And I'm using here the drill, for example, but it could be any other electrical appliance. And we can test this using PAT testers, so portable appliance testers. Also, in case those electrical devices have any moving parts, so any mechanical parts, when they get faulty, they will overheat. So for that, we have thermal imagers of KT series. Now, another device that we can find, this is a permanently installed device. And this is very similar. Here on the connection, we need to check short circuit loop, RCDs, insulation resistance meter, insulation resistance, phase rotation, and the level of voltage. So we have all different single function meters here, MZC for short circuit loop, MRP for RCDs, MIC for insulation resistance, TKF, that's a phase rotation meter, testers of P series, that's for voltage. And again, the MPI series, so multifunction meters, they have all these functions in one meter. And regarding the device which is permanently connected, we can test it with PAT meters, so portable appliance testers, and any moving parts which may be overheating, we can find this with our thermal imagers of KT series. Now let's look at any rotating equipment. So motors, generators, the moving rotating equipment. Here we will need to check insulation of the windings using the MIC series meters. And we can check continuity of those windings with MMR meters, the micrometers. We can check phase rotation with the TKF. We can check any overheating parts with thermal imagers, KT series, or optical pyrometers, DIT series. So these are the meters. We can also check the power quality using PQM meters. Now, further on, when we get to the building, we can find the light. So here we can check the short circuit loop between the cover of the lamp and the ground channel. So for that is there are meters of MZC series, so for short circuit loop measurement, or this is one of the function in the multifunction meters MPI series. Now, also when we are talking about the light, there might be different regulations for different workspaces, like the office desk, production line, conference room, and any different type of working places, also together with emergency exit lights. So we can check light intensity with LXP meters. So these are our light intensity meters. And also MPI 530 and higher models, they have possibility to use the optional adapter to check light intensity. Now, in case this industrial customer decided to go green and they have solar panels, we will check them similar like in case of a solar panel plant. So PVM 1020 or the MPI 540 PV together with IRM 1 meter. So this whole combination will give us a chance to check electrical safety of the panels together with the solar influence, so the irradiance meters. Again, any overheating parts we can detect using thermal imagers, so the KT series. Then we have the inverter, so the DC to AC box. And again, we can check this with the PVM 1020, MPI 540 PV, or any overheating parts using thermal imagers of KT series. Further on, in case this industrial consumer or office building has here a special grounding for thunder protection, then we will need to use MRU 200. So the one with the impulse method to simulate the shape of the current caused by the thunder strike. So coming back to the earthing, if this is just a regular factory or regular office building without solar panels, without thunder protection, then we can use any of the models from MRU series, our ground resistance meters. In case we have solar panels, then we need to treat this as the solar power plant, and we will need MRU 120 or MRU 200. And in case we have a thunder strike protection on some tall office buildings, on some special industrial plants, then we're gonna need MRU 200. And one more thing, when we can perform energy audit of the whole building, regardless if it's a residential, commercial or industrial, we can use thermal imagers to make sure that the air conditioning stays in or the heating stays in, depending if the building is in a hot or a cold area. All right, so those were general industrial consumers. And now let's look at some particular types of consumers. So we have here a railway, we have a mining station. Also, we will look at the welding and charging of electrical vehicles. So first of all, let's look at the railway. So railway will get its power from some transmission or distribution network. So they will have a transformer, which we can check using MIC meters to check insulation resistance of the windings, micrometers to check the continuity in the windings, MZC meters, especially MZC 330, 320, or the older model 310 to check the short circuit loop here on the transformer. MRU 200 or 120 to check the earth resistance of the transformer. Then we can use a UV camera to make sure that there is no corona effect. Or in case we have connection with the cables, then we can check termination of these cables with a test PD meter to make sure that there are no partial discharges. Of course, any faulty overheating element can be checked with the thermal imagers, so KT series, and we can check the power quality with the PQM meters to make sure that the power that we receive is good, and also to make sure that there are no distortions coming from the trains. Now from the transformer, we will have a connection to the overhead line in case we are talking here about electric trains especially. So these overhead lines, we can check their towers. So there will have some insulators, similar like the transmission towers. We can check those insulators with meters of MIC series, insulation resistance meters. We can check the ground of the of such tower using the MRU 200 meter. And in case there are any overheating components, we can find them with thermal imagers, so the KT series. Now, as we look at the line itself, we can check its continuity with the micrometers, the MMR series, and overheating parts with thermal imagers of KT series. Okay, so that was the overhead infrastructure. Now let's look at what we can have on the ground. So here are the rails on which the train is going. And in case of the rails, what we can do here? The rails, they provide the ground for the train. So we need to make sure that there is the continuity. And we can check this with the micrometers of MMR series. So typically we test the, say, 1 meter of the rail without connection, and then make sure, and then test a different 1 meter where we have a connection between two rails. And those should have about same values to make sure that the rail are continuous. Also, as the rail provides the grounding for the train, we need to check with the micrometers the continuity. So between the wheels here on the train and the rail, there need to be a continuity. Also, we can spot if any mechanical elements are overheating, so they are faulty, together with thermal imagers of KT series. Okay, now if we have any cables going along the rail, so for any type of signaling cables, then we can track them using locators of LKZ series and make sure that there are no defects inside the cable using TDR series, the time domain reflectometer. Okay, one more thing for all of the trains. So they have some pantograph on top, which connects to the power. And here we can use MIC series meters, especially 5 kV, 10 kV, or 15 kV. And here we need to make sure that the insulators on which this pantograph is standing, that they are correct. So we would connect the insulation resistance meter to the pantograph and down below to the roof of the engine, and then we will make sure that the insulation resistance is correct. Okay, now let's look inside the train engine and see what is going on over here. And here, depending on the country and depending on the supply, we can have different trains, and it might be a little bit difficult. Because in some countries, like for example in Poland, we have a high voltage DC lines supplying the trains. But in other countries, just like our neighbors in Germany, they have AC line. So here we can find different parts inside the train engine. And manufacturers, they got smart, so they can either get the power from DC or power from AC. So actually one train engine can go through Poland and across border to Germany and further on. Inside train engines, we can find the supply systems for both AC or DC power from the overhead line. So definitely there are inverters, there are rectifiers, and there are some generators. So the generators, we can check, the transformers, we can check with insulation resistance meters, MIC series. We can check continuity here of the windings using micrometers, as well as we can check continuity of all of the system. Then we can check short circuit using the MZC meters, and of course any overheating components with the thermal imaging cameras. Now, now there might be an auxiliary rectifier. That would be the next part inside the train engine. And we can find some inverters. So then the train conductor is steering with AC the power that goes to the wheels. Now what we can do here, so we can check the cables inside the engine. So for that we have the time domain reflectometer, the TDR series, or we can use to check continuity between them, we can use the micrometers of MMR series. Further on, to power the wheels, we have some type of a motor. So here the motor, we can check the continuity of the windings with the micrometers, or insulation resistance with the insulation resistance meters, MIC series. And of course, any mechanical components which could be faulty, they will be overheating. And we will find this using thermal imagers of KT series. Okay, so those were the electrical and mechanical parts of the railway system. And now we can find also the pneumatic brake hose. So at the end of the train engine and between each of the wagons, we have pneumatic connections. They are mostly used for the brakes on the wheels of the trains. And now we need to make sure that there are no leakages to this pneumatic system, and we can do this using the TUD. So our leakage detection, the ultrasonic leakage detector, does the TUD1. And of course, in case we get the leakage, then the brakes may not work correctly on the train, and we wouldn't like to be on such train. Okay. All right. So yeah. So this is the railway system. Now let's look at some other types of energy consumers, which are say some type of typical. Okay, Robert is writing me here. So yeah, so we are looking right now at mining. So in case of a mining, we have some infrastructure on the ground and we have some infrastructure under the ground. So here are two tunnels underneath the ground. And of course, above the ground, when we have any office buildings, any industrial buildings, we can treat them same as the industrial consumer, which I have shown you earlier. But as we look at the underground, as we look at the elevators, as we look at any lines for transmission of the coal or whatever they are mining for, then here's our system. So okay, so first of all, we get the transformer, we get some power coming in from the transmission and distribution system. And in most of the minings, this will be the IT distribution system. So IT means that the central point of the transformer is insulated. And here, of course, we can also measure such transformers. So we will need to check insulation resistance with MIC series meters, any continuity with the micrometers, MMR series, short circuit loop with MZC meters, so the short circuit loop impedance meters. We can check here for any corona effect on the overhead parts, so that's the UV camera. In case we have cables, we can check for partial discharge on termination of the cables using test PD meters, any overheating elements with thermal imagers, and the quality of power with the PQM meters. Now you may notice I didn't say anything about the grounding. That's because the transformer is insulated. Okay, so this is our transformer. Now let's look at some other parts, like what we can find here in the mines. So first, on the ground, we will see the elevators that go underneath. So here for this, we need to check insulation resistance with MIC meters, continuity with micrometers, MMR series, short circuit loop with MZC series, the short circuit loop meters, or we can just use MPI meter, which has all these functions embedded. But here we will need MPI 530 IT, MPI 540, or MPI 540 PV. So these are the three meters which are designed especially to handle the IT type of distribution systems. Further on, we can check if there are any mechanical components on the elevator which are overheating using thermal imagers of KT series. And we can check the power quality using the PQM meters. And again, the elevators, that's some special type of the load. Okay, so with the elevator, we go under the ground. And what we can find here under the ground? Well, definitely there are some switching boxes. And here we need to check insulation resistance using the MIC series meters. We can check short circuit loop using the MZC series meters, continuity with micrometers, MMR series, or again, one meter which has all these functions embedded, so the MPI meters. Of course, we need to remember to make sure that these are the ones working with the IT distribution system, which is MPI 530 IT, MPI 540, or MPI 540 PV. Okay, further on, what we can find here under the ground. So there will be different cables in the walls. So we can make sure that these cables are correct using the TDR. And in case we need to trace them or we need to find a special breaker for each cable, we can use the LKZ720. So LKZ720. Now, further on, we can find different electrical devices connected to the network, and we can check their safety using PAT testers, so portable appliance tester. And we can find the light underneath the ground, obviously, so the miners know where they are going, what they are doing. And here we can check the light intensity using the LXP meters. So the regular working light, the emergency exit lights, that's LXP series. And also with the MPI meters and optional LP adapter, we can check the intensity of light as well. Okay, so that was the electrical systems and some devices that can be used under the ground. And of course, we have the transmission line for transmission of different materials that are being mined here by the miners. So the coal, some stones and rocks. What else they could mine for? Copper, gold, or any metals. They will be transmitted on these transmission lines. And here we can find any faulty mechanical components by finding those overheating components with thermal imagers of KT series. And we'll find here also the motor. So something needs to power this transmission line. And the motor, as well as any other rotating equipment, we will check here insulation resistance with MIC series meters. We can check the continuity in the windings with micrometers, MMR series, and any overheating components, again, with thermal imagers, so KT or DIT series. Now, these transmission paths, these transmission lines, they can be also found above the ground. So we will get the coal or the metals or stone or any other material that is being mined. we will transmit it from under the ground, then through the elevator on the ground, and then we will put this on transmission lines on the ground. So here, same, if we have the motor, we test it with insulation resistance meters and micrometers. Any overheating components in the motor, that's thermal imagers, same here, and any mechanical elements that will overheat along the line, we can find with thermal imaging cameras. And further on, we can have cables supplying powers to these lines. So we can trace them using LKZ series locators. We can check any faults in the cables using time domain reflectometer, the TDR series, and we can check insulation resistance of these cables using MIC insulation resistance meters. So basically, these are different parts which we can find in the mine. I think it's kind of similar to other industrial consumers. Just we need to remember that most of the mines, they are working with IT distribution systems, and therefore we need to use some special meters like the multifunction meters of MPI series that will work with the IT distribution systems. So the MPI 530 IT, MPI 540, or MPI 540 PV. Okay, now what else we can find with the industrial consumers? So there could be some plants which are welding. Those are, for example, some industrial plants for automotive industries, like they have the welding robots, or they could be portable welding machines here in many different industrial plants that we also need to check. So if we have the mobile welding machine, we need to treat this as any other portable electrical appliance. So we can test it with a PAT series meter. However, there are some specific tests that we need to perform, especially on the welding machines, which are available with PAT 86. So this is the model designed for welding machines. Now, in case we are thinking about the welding robots, here we need to check the continuity of the welding cable. So for that, we can use the micrometers of the MMR series. Okay, so these are the plants which do welding. And now let's look at one more thing. Let's look at automotive industry, which these days is changing to electrical vehicles. And we can think about just electrical cars, like we can find, say, Nissan Leaf or Tesla or any other electrical vehicle that we can charge at home. We can charge it at the supermarket, at the hotel, at some office buildings where we can find the chargers. But also in case of industrial users, they can have some of their own electric cars just working along the plant or along the mine or along just internally within their industrial facilities. Well, anyway, all of these cars, electrical, regardless if it's a truck, a bus, a personal vehicle, or some special utility vehicle, they need to be charged. So often when we are thinking about electrical cars, we just think the car and the charger. So, well, somewhere we need to get this power from. So it comes from the grid, from the transmission line, then there's transformer, meter, and the panel. So here we can check all of these components of the transmission line with similar meters that I have shown you before. So insulation resistance, for insulation resistance check, MZC series meters for a short circuit loop, MRU meters for ground resistance, MMR micrometers for continuity, and so on. Or we can just use MPI series meters, the multifunction meter, which has all these functions embedded. Also, we can use the PQM meters to check the power quality, once to check if the quality of power we receive is good. And the other thing is that the car chargers, they can cause some distortions in the system. So we can check the quality of the power and if there are any distortions coming from the car charging. Now we can charge the cars from the charging station. So now let's get into the charging stations and the supply equipment. So here we can check this using MPI, the multifunction meter, and the EVSE01 adapter. So the EVSE01 adapter, this is a special adapter that works with our multifunction meters, and it has a plug that works with the type 2 socket, plug type 2, which you can connect in the charging station and then perform all the electrical tests. Of course, here the test of electrical safety, they include insulation resistance, RCD test, short circuit loop, and so on. Same as for any other type of electrical network, the regular one which we can find at home or at the industrial facility. But also we need to put the charging station in certain conditions to check it. For example, simulating charging of a vehicle, simulating an error, and thanks to the EVSE01 adapter, we can do that. Now, we can use the EVSE01 adapter with any of the multifunction meters of the MPI series. We just need to remember that the functionality will be same as the functionality of the MPI meter itself. Like, for example, the simplest model, MPI 502, it can only check a short circuit loop and the RCD parameters. So when we connect it to the EVSE01 adapter, also on the charging stations, we will be able to check only short circuit loop and RCD parameters. Now, if we go with our top model, MPI 540 PV, then we can check all of the components of electrical safety of the charging station. And also this new MPI 540 PV has a possibility to program a certain sequence. So the meter will just perform all the measurements in a sequence. So we just connect the plug into a charging station, press the start button, and the meter will lead us through all different types of the tests. So that is very convenient. All right, so those were different types of consumers. I would like to highlight one more type of application, and this is power quality. And here, I'm not going to show you any type of consumer where we are using power quality, because we can use it everywhere, from residential consumers, office, commercial, industrial, mining, railway, airports, well, pretty much everywhere. But let's discuss here a particular situation where we need to check power quality. So we need to check the power quality where we need precision. So especially different computer systems, especially server farms, if we have some distortion in the power, then our servers will malfunction, and we don't want that. Same with radio equipment and radars. So any different types of communication radar systems. Also, in case of airports, they also have radars. Then, when we have some specialized equipment, like for example, in hospitals, we can have tomographs. Also, if we get some distortion in the power, then our equipment may malfunction. And again, we don't want that. So anywhere where we need a precise, very good quality of power, we can use the power quality meters of PQM series. The other application will be checking the source of power. So here we have the EN5160, which describes the quality of the power. And this is the general standard, and all of our meters can make measurements according to the standard. Depending further on, we have meters of class S or higher class A. Also, the UPS, so uninterrupted power supply. When we have the string of batteries, that will work in case of any failure to the grid. We need to make sure that we get good quality of power from this UPS system. Similar in case of diesel generators. So we can find them at the hospitals, at the hotels, at the commercial buildings. So again, when we are talking about some power supply, when we are not getting power from the grid, then we have different systems like UPS or diesel generators. We need to make sure that we get good power from those systems. The next thing are spread energy sources. And here where we have residential photovoltaics, wind or water, right now many residents, they want to go green, but their photovoltaic panels may be supplying a kind of poor energy. And when we have plenty of those residents, each one supplying a little bit of a poor energy, then the summary may be, it may disturb our power grid system. So here also we need to use power quality meters to make sure that all these residents, they don't disturb our power system. And of course, on a power source, we can check for any poorly designed installation. Now the next application where we can use power quality meters, that will be checking for high loads, especially, they could be working in a different modes like continuous, periodic, or impulse. So especially the ones that work in an impulse or a periodic way, they can cause some distortion. So, for example, a furnace. So in different steel mills, the furnace, they need a lot of power to heat up. We can look at pumps. So at any water pumping stations, gas pumping stations, they also need a lot of power. Then we have a press, a stone splitter, which is working in impulse mode to split the stones. We can look at different turbines, engines, especially line engines. When we have in some industrial facilities the robots that goes, that's an impulse working mode, and especially if they need a lot of power, then they can do some strange things to our power network. Then welding, this might be a problem as well. CNC, elevators. So here different office buildings, hotels, hospitals, we have the elevators. They require a lot of energy, and they're working in a certain undescribed periodic mode, because whenever people decide to get in an elevator, then we start a very powerful engine to lift it or to lower down the elevator. What else? Electrical vehicle charging. This can also be a high load, especially as we have parking in front of a supermarket or a hotel, with adjusted right now for electrical vehicles. Many people can plug their cars in the same time. So when we have a full parking lot, this could be a high load. And here, depending what you see, what customers you face, you can talk with them what type of devices that are using. In case these are the high load devices, they may need to use a power quality meter. Now, another type of application where we can use power quality meter, that's the unbalance. So here, generally, we are talking about the three-phase systems, and we can find different motors, engines, or transformers. In case they work incorrectly, they can cause some unbalance to the system. So the three-phase are unbalanced, they are working in some strange mode. and uneven phase load distribution in any three-phase systems. So even, let's say, for example, in a hotel, they have a three-phase supply system, but there is too much connected on one of the phases, which will mess up our power quality. Also, we may want to think about electrical vehicle charging. So when we have single-phase AC chargers, and there are a few of them in the parking lot. Say we have 6 chargers, each one is single phase. We did everything correctly because we connected 2 of the chargers to each phase. But apparently we have just 2 cars parked and they are at the same phase, so they can cause some unbalance. Of course, the way to prevent this would be to put 3-phase chargers. That would be easier. Okay, what else we have here for power quality applications? So different rectifiers and inverters. These things will put a lot of distortion and harmonics into our power quality, into our system. So here we need to think about photocopy, different Xerox machines, LED lighting, and any types of chargers for the computers, for the cell phones, for well, basically everything that is charged with the DC power. So and we have plenty of those equipment at home, like chargers for cell phones, chargers for computers, chargers for TV. A lot of those chargers. Okay, so those were the applications for power quality. Now, as we are choosing the right meter, we need to remember that we have a certain measurement category. Cat 4, this refers to devices connected directly at the low voltage system source. So here with Cat 4, we can check the transformers. With Cat 3, we can check installations inside the building. And Cat 2, these are the devices for, well, these are the meters for devices connected to low voltage installations. Also, we can see something like Cat 3 divided by a certain number of volts. So we have, let's say, Cat 3 slash 300 volts. 300 volts. Okay, so what does it mean to us? If we have a system like we got here in Europe, 230 volts phase to ground, 400 between the phases. So can we use Cat 3 300 volts to check between the phases? And there's 400 volts and this is only 300 marked safety. Well, yes, because this voltage here that is stated at the measurement category, it refers to phase to ground voltage. So when we have a system 230 phase to ground, 400 between the phases, then we can use a meter with a safety marked as 300 volts, because phase to ground we have only 230 and not 300. Okay, so those were our meters. Now let's look at other things that we do at Sonel. So we have accredited testing and calibration laboratory. Then, of course, we would like all our customers to send our meters for calibration. We recommend to check our meters once every year, so once every 12 months, to make sure that they are measuring correctly. But here, as we are talking about Southeast Asia, well, you are quite far away from Poland, so there will be long delivery times and probably some customs associated with this. So here, well, you can use any of your local laboratory to calibrate our meters. But again, when you are going to the customers, you can offer them our calibration certificate by accredited laboratory as an optional accessory to the meters. So this is basically the proof that the meter is working correctly. So let's say what happens in case of a fault. Well, there's a fault to the installation. Let's say there was a fire and insurance company comes. So first they ask, okay, has your installation been checked? And then we need to show the report that the installation was checked and it was working correctly. And then the insurance company will ask, okay, so was it checked with the correctly working meter? And this is the moment when we pull out the certificate of calibration to prove that the meter that we used to check electrical installation was working correctly. And that's where we need the meters, well, the calibration certificate. So again, calibration certificate by accredited laboratory. You can offer this as an optional, let's call it optional accessories to our meters, and you can raise the price, and well, our guys at laboratory will have something to do. Now, the other thing that we do, these are trainings. And we can offer those trainings stationary. So, well, you can come to Sonel. You are always welcome to see all of our meters. Or we can do the online trainings like we do right now. As well as I or any of my colleagues, we can travel to Southeast Asia and to perform the trainings for the customers. So here, let's say price-wise and profit-wise, well, I will leave this up to you and up to Robert, depending how we manage different customers. As it comes to you as our branch and as it comes to our distributors among Southeast Asia, I think we can perform these trainings free of charge, especially the online trainings, as we want you and our distributors to know our products, as it actually helps the sales. So at any request, I can perform these trainings to you. Now, as it comes to end customers, well, here you can use a training, for example, to build up some special value to say to a tender. There is a tender, there's a project, and people want a meter, and then you can give them additionally a training to that. And well, here pretty much this depends on you. As I said, I can visit the customer. I can make online training to a customer. So at your request, we can arrange this training. Also, I'm planning to do the open online trainings for everybody. So for this, just visit our website, and yeah, later this month I will make the schedule for different trainings that will happen among a few months in the future. Okay, so that was our trainings, and one more field of activity. This is the electronic assembly. So here, as we are assembling electronics in our meters, we have also the possibility to assemble the electronics at a certain request. And here we have a possibility to help the customers to design the electronics. We have the possibility to help purchase different components. And of course, we have all the power to assemble the PCB. So we have the automatic assembly, and for the larger components, we have the manual assembly. We have special soldering machines. We have a quality check with the cameras. So we can provide a really good quality of electronic assembly. And we have some customers worldwide. I think the biggest one right now is Lincoln Electric. So that's a US company which is making welding machines. So we make the PCBs for these welding machines. We assemble them. Now, if you came across any customer that might be possibly interested in having their electronics assembled, then well, just contact with us, and I bet you will have some profit out of it as well. Okay, so those were all the different things that we do at Sonel. Of course, our main field, this is the production and sales of the meters for electrical installations and all the things associated with these meters. So the calibration laboratory, the trainings, and any help to the end users. Okay, so right now, let's talk maybe about some applications which are typical with you and what meters you see the most interesting. And later on, we need to plan some trainings based for the particular meters. So I think right now we can determine what is the most interesting for you and what trainings to do in the future. Of course, right now I cannot come to Singapore and you cannot come to Poland, but once the travel will be available, then I hope we can also see each other and see the meter, touch it together, test it at some test site, either at Sonel, we have a nice test site, or we can go together to a customer and make some testing. Okay, so please turn on your microphones and let me know what you are interested in.
Hi, definitely the solar installation testers will be one of it, and the other one will be the EVSE tester.
The excuse me, the what?
EVSE, the electric vehicle.
EVSE, the electrical vehicle.
Mm-hmm. So you have the PV tester, the electrical vehicle tester, and
Yes.
of course the ground tester as well. And the ground tester, I think I would like to elaborate that probably we can also highlight a bit of a training where we can actually talk about how the type of selection for ground testing we can actually qualify either the 4-pole, the 3-pole, the single clamp, and the double clamp method. Where in what situation you need to choose it, and from there you basically can match it down to the model of Sonel testers. So it will be something that we can actually carry and educate to something like a refresher training for electrician as well, and also for the education. If we manage to go into education, polytechnics, for example, to talk about Sonel. Of course, the not forgetting the isolation testers, that is a must. And PQ meters as well. This is also very important.
Okay. All right. So definitely we can do that. Okay, about the earth resistance. I know there was somewhere an article describing which meters are suitable for which type of application and which type of customers. So I think I can get that.
Okay.
And I also have a training which describes some say hard conditions and how to measure in hard conditions. So we can do that. Regarding solar and electrical vehicle charging, because this is also associated with the multifunction meters of MPI series. So I think I can do this in one training. Maybe this one will be a little bit longer, but we can discuss all the different types of multifunction meters together with photovoltaics, together with electrical vehicle, and see what are the differences between them. Insulation resistance meters. Well, yeah, I have a training ready for that. And on power quality, oh boy, here I know we have different leaflets describing different applications and so on. And regarding the training, I can show you the operation of the Sonel analyzers. So the software that helps you to set up the meter and later analyze the recording from the power quality meter. And I think I did it already with Joseph, but if you want, we can do this once again.
Okay, thank you.
Okay, so definitely I will send you the materials. I wonder, Robert, if you want to say a few words. Okay. All right.
No, I'm okay. I think training is okay. I think Alex probably have quite a bit of requirement because this first time that he attended this, so he have some requirements to train for his customer as well. Yeah.
Mhm. Okay. All right. So I think we can arrange. Will be the MPI, so solar and EVSC, and the multifunction meters. That will be one. Earth resistance 2, insulation, okay, PQM, that's 3, and insulation. Here I have a few trainings depending on the model, but basically the whole idea of insulation resistance measurement and the physics behind it and the standards behind it, these are the same. So I have there are differences between the operation of the meter, but I think we can do it in 1 or 2 trainings. So we got 1, 2, 3, 4 trainings. So we will need to set up certain times and dates and just do it.
How about the test PD? Is that a complicated product?
Okay, I don't
Test
have.
PD means
I don't
to
have.
test the cable, right? PD for the cables, right?
Yes, that's correct. So you test for
Is
partial
that
discharge.
is there some practical? I saw the video. Is just to check for PD. I think it's quite interesting product. Basically for the utility market. So it's something that we want to highlight the applications or how should we do it so that we can actually drive these products into the utility market. I think it's quite interesting product. Yeah.
Oh, yeah, that's true. Here, mostly power utility, medium and high voltage, and they will check at termination of the cable. So, when they connect the cable to a transformer station or somewhere else, to check if there are any partial discharges. Also, in case they have a break in the cable and they repair it, so they put a connection inside, they need to test it. So that's the test PD. At this moment, I don't
The
have
application.
ready training, but I think I can prepare it. So maybe later we can do that.
Okay. Thank you.
Okay. All right. So we have 1, 2, 3, 4, 5 different trainings. So yeah. Okay. So we need to set some times and dates. And I believe this will be pretty much it. And just do it. And maybe later when the travel will be available, then we can see each other and touch the meter. Then it's more fun than just doing those online trainings and work on some live objects. Okay, so yeah, so today is a Wednesday. Well, what else we have? Okay, I'm busy on the 15th. I wonder if you would like any training, say, next week, any day, any time. I'm pretty much open whole week. Hold on, let me check. No, this is online. Online. Oh, Okay, so I'm checking here not to get conflict with other online trainings that we have. But let's say next week I'm available Monday, Tuesday. Wednesday busy, Thursday busy. Yeah, so Monday or Tuesday. If you would like any training for next week, Monday or Tuesday, we can do that. If the time is good for you. Yep. Okay, or we can, well, this, oh, okay, we have someone typing. Or if you want, you can discuss this and we can talk about this over emails. Okay, Tuesday is fine. Same time, so like today, that was 8 a.m. My time. Sorry, I don't know what time was in Singapore. Okay, so yeah, so Tuesday, 8 a.m. Okay, what we would like to start with? Okay, so that's good. That's my 8 a.m. Okay, any particular subject that you would like to start with? Only a test PD, let's leave it for later because I don't have ready presentation. I have to make it. Okay, by the way, I will stop the recording because we don't